Welcome everyone to this wonderful playlist of the digital electronics. Here we are dealing with all the topics of the digital electronics, and by far in the last 20 videos we have covered all the number system and all the mathematical operations on the number system. From today we are starting the new topic, that is binary codes. Now meaning of the binary codes is when any device, let's say you are sending any WhatsApp message to your friend, over here what is happening inside is your messages are getting converted into the binary numbers, and after that they are encrypted and then it is sent to the network and then it is received by the other phone of your friend. So over there also the decryption of the message happens and then the particular friend can see your messages properly. So over here in your mobile phone, encryption process is happening before your message is actually transmitted. So why the encryption is required? Because let's say in between the network, whenever your message is in the network, if anybody is stealing your messages, so he or she should not be understanding all the vital information, all of your messages. Sometimes it may happen that all the messages are important for the people like us. We are the normal people, our messages are not that much important. But let's say you are the army person, let's say you are the very important person of the country, then your messages are very crucial, right? All the information can be manipulated and it can be used against the particular country or to take any dangerous action. So for that purpose, encryption is very much required. Now all the data are the binary data and all the data is encrypted using some methods. So over here we will see the overview of how to encrypt all the binary numbers, and the encrypted form of the binary numbers are known as the binary codes. So over here we will see several methods using which we can encode or we can encrypt the binary numbers. So without wasting any time, let's start this topic. So as discussed, what we can define about the binary codes. Binary codes are symbols used to encode the binary numbers, right? So basically when any number is encoded using any symbols, those are basically your binary codes. So now we will see the classification of the binary codes. So there are 6 broad categories under which all the binary codes are classified, right? So the classification of the binary codes, okay. So there are 6 categories. The first one is the weighted binary code. The second one is non-weighted binary code, right? Non-weighted binary code. Third one is reflective binary code. Fourth one is sequential binary code. Right? Fifth one that we are having is alphanumerical binary code. And the last one, and very important from the logical point of view and from the practical point of view also, that is error detecting and correcting code. Okay, so we have 6 categories of the binary code. Today we will understand what are the meanings of these 6 categories, and then in the upcoming videos we will be covering the different binary codes, right? So the starting with the first one, that is weighted binary code, right? So in this code, each digit position in the number represents what it represents, any specific weight. If the simple example, if I take of the decimal number, let's say my decimal number is 5, 6 and 7, right? So if we speak about the 7, the weight of the 7 is 1, weight of the 6 is 10 and weight of the 5 is 100, right? So basically this number is 5 into 100 plus 6 into 10 plus 7 into 1, that is equal to 567. So each digit over here in 567, they are having some weights. So when any digits are having weight, they are known as the weighted binary codes, right? Similarly in the binary also, binary is 8421. So each digit is having the code, so each digit is having the weight like 8421. If we go on, then it is 1632 likewise, right? So binary number and the decimal number are basically weighted binary codes. Okay, then if we go to the next one, that is non-weighted binary codes. So from the name itself, it is very clear that each digit position is not having any specific weight, okay? So here the digit positions are not having any specific weight. The famous example of this type of the code is XS3 binary code. That is XS3 binary code. This in detail we will cover in the upcoming video, but right now you just remember that XS3 is the non-weighted binary code. Okay, the next one that we have seen is the reflective binary code, right? So here the name reflective says there should be some reflection between the binary codes. So the logic over here is, if you are writing binary code of 9, right? Binary code of 9, this should be equal to the complement of the binary code of 0. This should be equal to the complement of binary code of 0. Similarly, binary code of 8 should be the complement of the binary code 1, right? Similarly, 7 should be the complement of the binary code 2, and likewise 5 or 4 should be the binary code of 5. So this is how the reflective code works, right? 0 is reflection of 9, then 7 is reflection of 2. Likewise, there is a reflection happening. That is why this type of binary codes are known as the reflective binary codes. So 2421 type of the code that we will see in the upcoming video, that is the example of the reflective binary code, right? Then moving on to the next one, that is sequential binary code. So in this, not each, but the digit position or weight of the digit position should be greater than the weight of the previous digit position. Okay, weight of the previous digit position. So if I give you the simple example of 8421, right? Our binary number is 8421 code, right? So the first unit or the first digit is having the weight 1, second one is having the weight 2, third one is having the weight 4, fourth one is having the weight 8. So if we go from left to right, that means from LSB to MSB, the weights are increasing. The weights are increasing in the sequence. They are increasing in the sequence. So such type of the binary codes are sequential binary codes. When you go from left to right, your weights are increasing in the order, right? So such type of the codes are sequential binary codes. Now we will discuss alphanumerical binary codes. So codes in which alphabets as well as numbers are used. The very famous example is ASCII number system. I guess you have heard about the ASCII in maybe in 10th or 12th, right? So ASCII is basically American standard code for information interchange, right? So we will be covering all these examples that we are discussing in the detail, that is in the upcoming videos. Here we are broadly understanding all the categories. Now we will discuss the last one and the very important one. So next one is error detecting and correcting code. correcting code. Okay, so these are the type of the codes that allows you to detect the error in the message that you have sent, and sometimes it is allow you to correct the error also. So the type of codes which allows you to detect the error as well as to correct the error, this type of the codes are known as the error detecting and correcting code. If you simply see the logic of this type of the code is when, let's say, you are sending one, let's say this is your computer and this is your friend's computer. Okay, so what you want to do, you want to send the number or a message to meet your friend. So you want to send the message that let's meet at 5 p.m. Okay, so what you are sending, you are sending the message to meet at 5 p.m. Okay, so you want to send the message that let's meet at 5 p.m. So 5 is basically 101. So you are sending 101 over the transmission, right? And your friend, so this is you and this is your friend. So your friend would be receiving the message 101. It is supposed to receive the message 101, but let's say due to the interference in the communication or due to the noise in the communication, this 101 is received as 111. So you have told your friend to meet at 5 p.m. but he is reading 7 p.m. because it has received 111. So this should not happen, right? This should not happen. So there should be some integrity maintained. Integrity should be maintained, right? Should be maintained when you are transmitting all the crucial information, right? So for that, in order to do that, error detecting and correcting code are allowing you to detect the error in the message you sent, and that it is doing by adding one or more than one extra bits along with the message, right? So over here I am adding 0 with my message 101. So this is my message and this is the extra bit I have added over here, right? Meaning of the extra bit is this 0 represents that I have even number of 1 in the message, right? Even number of 1 in my message. So in my message, if you see, I have twice I am getting the 1. So that is number of 1 is equal to 2. This I am transmitting, and now due to the noise, the message received is 111, right? The message received is 111, but I will be now checking the error on the first bit. I will be checking my error on the first bit. My first bit is clearly telling me that the message should have even number of 1. The message should have even number of 1. Are you clear? But when I check my message, when I'm checking my message, I'm getting 3 times 1, right? What I'm getting 3 times 1. So when I'm getting 3 times 1, that means it is not satisfying. It is not satisfying this particular condition, and that is why I am sure that the message that I have received is containing error. It is containing error, right? So this is just a basic example of how you detect the error using this type of code, right? In detail, we will cover all the error detecting and correcting code, and that will be very important topic of this binary course, because all the other codes are very easy and very simple, but when you go for error detecting and correcting, the level is suddenly high, right? A level becomes suddenly high. So over there we will be deeply understanding. Maybe the videos will be longer for that type of the topic, but our aim is to understand the topics in very detailed manner, right? So with this we will end this video, and before we go, I request you to subscribe this channel, because when you subscribe the channel, it is kind of a motivation for me to bringing this type of content to you regularly on this channel. And that's it, I guess. Let's end the video. We'll meet you in the next video. Thank you very much.